Okay, seventh graders, here is the second part of today's lesson. We're moving on to 9.3, which is finding the area of irregular figures. So something that you're not used to seeing. It's probably going to be a combination of two different shapes, or maybe they're like slightly sideways or something different. Before we can do that, I need you guys to make sure you have these three formulas written down in your notes and also on a note card, each one of those separate note cards. Okay, so you're going to have a total of 4 note cards today. These three, and actually you should have this one already done. Okay, so the next two plus one other definition that we're going to come up here on a minute. But from the last section we just went through, we talked about area of a circle being pi times r squared, pi times radius squared. Okay, you should know the next two formulas. In case you don't, I have them written down. Area of a rectangle, which also translates to a square, as we know, that's length times width. And then finally, area of a triangle is 1/2 times the base times the height. Okay, so make sure you have those formulas both in your notes and on a note card so you can refer to them as you need to. All right, so we are going to talk about irregular shapes and something called a composite figure. So, oopsies. So we are going to write down the definition for a composite figure. You can stop at this period right here. Okay, but the rest of the stuff is important. So if you want to take like brief notes on it, that's fine. But the definition of a composite figure is something that's made up of simple geometric shapes, such as triangles or rectangles. So a composite figure has more than one thing. Think of like something like a compound sentence, for example. It has two parts to it. Same thing with composite figure. There's two or more parts involved. Okay. When we go to figure out the area of a composite figure, we're going to separate out the shapes as best we can, find those areas individually, and then put them together. Okay, so that's what this slide is talking about. The next slide, I don't want you to necessarily write it down if you don't have graph paper. If you want to, you can. You can, like I said before, you can always pause these videos if you feel like you want to write something down, okay? But sometimes when I go quickly through the slides, it's me thinking you're not going to write down this stuff for your notes, okay? So just kind of keep that in mind. But if I have something that looks like this has a whole bunch of shapes going on, doesn't it? This has got like, looks like a circle. You can probably somehow make like part of a rectangle or maybe do two triangles. This is hard to break down and figure out exactly what the area is. So what we do is we estimate by counting the number of units or boxes that we have in the grid. And then also estimating like half boxes or quarter boxes. So if you were to count all these up, you would get about 50. Okay, so if you have something like this, you would count up all the squares. So there's 45 squares that are full squares. Then we have about 10 half size squares. So like here's one, here's kind of one, it's a little bigger than half. Here's one. So we're going to count up our half squares. And even if it's like, for example, look at this one here. This is definitely not a half, but this is more than a half. So those are each kind of the average out to half squares. So when we count up all our figures, we end up getting about 50. Okay. This one's a little more cut and dry. Again, if you don't have graph paper, just kind of watch what I'm doing. But all these red blocks are full squares. The green ones are half squares. So if you count them up, you get 11 red squares and 8 green squares. And therefore you get 11 plus 4, which is 15. So there is about 15 yards in this diagram. So that's just estimating. What we're going to focus on for the most part is actually figuring out the area given some dimensions. Okay. So here, I want you to start back up with taking notes. So we have this irregularly shaped figure here. Okay, if I look very carefully, I have this figure right here, which is a half circle. And then I have this parallelogram. Okay, so we're going to find the area of the parallelogram, then the area of the circle, and then we're going to put the two together. Okay, I'm going to start off with the parallelogram. And we did not write this down at the beginning, but a parallelogram is very similar to a rectangle. Instead of length times width, it's base times height. So the area of the parallelogram is going to be the base of 16. I know 16 is on the top. It's down here too. So this is the base of 16 times the height of 9. And we end up with an area of 144. The 144 is just for this parallelogram up here. That's it. Nothing more. Okay? We have to now find the area of the half circle. So if you remember, if you recall back to the previous section, we're going to find the area of the circle and then divide it in half because it's a half circle or a semicircle. And when we do that, why is this not advancing? There we go. No, wait, what happened? Here we go. The area is going to be 1/2 pi r. That should be squared. Sorry about that. Make sure you put a squared right here. I don't know why. I'll fix that later. So we have 1/2 times 3.14 times 8 squared. If you're confused where the 8 came from, the diameter of the circle is 16. So half of 16 is 8. That's the radius. Okay, so when we do our calculations, we end up getting 100.48 for our semicircle. Okay. Now, what we're going to do is we're going to take our area of the parallelogram plus the area of the circle, half circle, and we're going to add them together. And we can now find the area of the composite irregular figure. So the area is about 244.48 meters squared. Okay, I know that's a lot, but if you separate out the two shapes and find the areas and approach it with that, mindset, just say, oh, it's not too bad. I just have a parallelogram, or I have a rectangle, or I have a triangle, or I have a circle. If you approach it that way, it's going to be a lot less daunting, if you will. Okay. All right. So moving right along, here is another irregular figure. And it looks like we have a triangle. So if we were to make like a dotted line going right down here. So dotted line going down here. We'd have a triangle, and then we have a rectangle. It looks like a square, but it's a rectangle because it's 8 by 9, not 9 by 9. It really looks like a square, but it's a rectangle. Okay, so if we look at the rectangle, we're going to take length times width, which is 8 times 9, and we're going to get 72. So this portion right here, the area is 72 yards squared. Okay, now we need to look at the triangle. The triangle is 1/2 base times height. Okay, so let's start off with the formula, 1/2 base times height. This 1/2 right here is a constant. It has nothing to do with any of the numbers that show up over here. Okay, so we're going to substitute 2 in for our base. The base is this down here, and the height is going to be this, which is 9. We're going to do our calculations, and we get the area of 9 for the triangle. Excuse me. So if we were to add those two numbers together, that'll give us the area of the total figure, which is 81, and don't forget your unit, yards squared. Okay. So that's that section in a nutshell. It was kind of fast. Like I said, pause the movie if you need to, or the video if you need to, and just try to, take the notes on that and make sure you know what's going on. If you have any questions, make sure you go ahead and send me a Zoom request or email me or something of that effect so we can get, squared away on this. The homework now, this is going to be the second part of your homework for Wednesday, is page 371, 7 to 17. Again, I'm going to have another separate Google form for you. And you just type the answers in there. If you're not able to make the squared symbol for the unit, that's okay. And that, just put a 2 so I know that you know it's squared. Okay. All right. Good luck. Have fun. Math is fun. Contact me if you need anything, and I will see you on Wednesday for our Zoom call, 1 o'clock. All right. Thanks. Bye.